Hello friends, myself Rajendra Mahajan presenting my video on Laplace transform. Let us solve the problem. Get a reduction formula for Laplace of t raised to n. Otherwise, find Laplace of t raised to n when n is positive integer. And to obtain it, we take the help of definition of Laplace transform. We know that Laplace transform of t raised to n, that is f of t, as per definition it is integration from 0 to infinity e raised to minus st into that function is here t raised to n and its integration with respect to dt. Equation 1. In this equation 1 we put st as a new variable y, suppose. Then we get the value of t as y by s. Differentiating it with respect to t, we get dt is equals to dy by s. As we are using the substitution, we find the new limits. For t is equals to 0, we get y is equals to 0, and for t is equals to infinity, we get y equals to infinity. Substituting all this information in equation 1, equation 1 becomes, therefore, Laplace transform of t raised to n is equals to, limit remains same, 0 to infinity, e raised to minus st, but st is y, therefore e raised to minus y. T is y by s and whole raised to n, and then dt is dy by s. There are two terms of s, first one and second one, combining that power and then taking it outside the integration sign, we get 1 upon s raised to n plus 1, integration from 0 to infinity e raised to minus y and y raised to n and its integration with respect to y. Then in this step we add 1 and subtract 1, and we know that result of gamma n. As per definition of gamma n, it is integration from 0 to infinity e raised to minus x, sum x raised to n minus 1, and its integration with respect to x is the value of gamma n. And therefore, using this information in equation 2, we get Laplace transform of t raised to n as 1 by s raised to n plus 1, no change. And comparing these two results, integral from 0 to infinity e raised to minus x, here we have e raised to minus y, sum x raised to n minus 1, here we have y raised to n plus 1 minus 1 with respect to x, with respect to y, and therefore as per definition it is nothing but gamma n, therefore it is gamma n plus 1. This is the formula, or we can rewrite this as gamma n plus 1 is n gamma n divided by s raised to n plus 1. Here that gamma n plus 1 is equal to n gamma n is the reduction formula for gamma n. Therefore, this is the first value. or Laplace of that t raised to n is that value of gamma n plus 1 is n factorial divided by s raised to n plus 1 if n is positive integer. Means there are two results. First one, Laplace transform of t raised to n is equals to gamma n plus 1, nothing but n gamma n divided by s raised to n plus 1. And if it is positive integer, then the Laplace transform of that t raised to n is n factorial divided by s raised to n plus 1. Second example, find inverse Laplace of one upon a square plus pi by 2. To find this, we take the help of this result. We know that inverse Laplace of 1 upon a square plus a square is 1 by a sine of 80, and therefore rewriting that term, inverse of 1 upon a square plus a square, therefore pi by 2 we write down in the form of a square, nothing but root of pi by 2 and its square. Square root and square get cancelled, we get the original term pi by 2, and therefore here the value of a is root of pi by 2, and therefore 1 by a means 1 upon root pi by 2 into sine of 80 sine of root pi by 2 times t. Value therefore it is root 2 by pi sine of root of pi by 2 times t as the required answer. Please like my video, share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe to my channel, and to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.